Let's go through liquid 1425 constraint subsequence sum. For this question, it gives us integer array nums and integer k. So you want to find a subsequence sum, which is will be maximal. But the subsequence, those kind of index, need to have this kind of condition. That is the next index with previous index will have a smaller equal to k. That means, for example, let's look at k equals 2, right? So if we select 10, then we can select uh, the next index can be 2 or can select 2 or minus 10, right? If we select 2, right, and the thing is that we cannot select more than k, right? So that means the next we can select either minus 10 or 5. So the maximum or subsequent sum is 10 to 520, right? So it returns 38, 37. So this question is almost very similar to this question of jump game 4, right? But the thing is that for the sum of these subsequences, we are able to mm, start at any index, and also we are able to stop at any index, right? Um, so um, if we do what we think about those kind of DP way, right, is that we may have int a equals nums of the length, and we have, for example, DP equals new int and in the what we have, for example, for int I equals to 0, I smaller than I plus plus, right? So for int j equals, for example, at least greater to 0, right? And I minus k and j plus k. Uh, j is smaller than I, j plus plus, right? Then we have dpi equals max dot max um, dpi. And mm, for example, dpj plus nums I, right? So here, for example, we set the dpi equals nums I, right? Like this. But for every dp, we have a result equals max dot max result in the dpi, right? But apparently this will be TLE, because we have two follows. That will be O(n) squared time complexity, right? So we need to get for this kind of sliding window, we should have a more efficient way to handle it. And for this kind of slide window, we can use the monotonic deck, right? So to do this, we need a data deck integer. That's called deck because new array deck. So um, what we do is that we are looking for this kind of index I is not included. So what we do is that we need to put this index and pull those kind of from those useless index from the deck from right at the last step, right? So the first step is we check the left boundary to see if we are able to pull from the left. And if the size, for example, the index is greater than k, then we pull from the left. And then we set this kind of DPI, right? And here we do processing, have our global result compare with the current DPI. And then we do while loop. In the end, we have a return result, right? So and so we need have a maximal result. So we need let's set int result equals we can put it here. Put result equals integer dot mean value. So what we do is that we'll say while this kind of if, right? Because this kind of um this index is we can use if, right? Because this index we are moving one by one. So if this kind of deck is not empty, let's still call it deck. And I minus deck dot peak first, right? If this size is greater than k, then we need to get rid of the left should use a pour first, right? So that can make sure the data staying in our deck is in the size k, right? And then we have DPI equals SI. So the thing is that if this deck is not empty and if this kind of deck is not empty and BP we write deck peak first is greater than zero, right? Because if it's negative, we have options. Do not choose the previous subsequences. So if it is positive, then we use the previous largest, right? So if the previous largest, for example, is negative number, but we can skip the previous, right? So if this is positive, then we have DPI plus equal to DP deck peak first, right? So here, for every DP, we need to compare with our global result, right? So result equals max result and the DPI. So here, this will be the while loop when we pull those kind of from the right, those kind of inefficiency element, right? Because we are we should for the future calculations, if in the deck there are DP which is smaller than current DP, and the index because it is smaller than I, right? So we'll never use this kind of DP value as a maximal DP in the future windows. So we'll say if while this is not empty and DP um, deck for last, if this is smaller equal to current DPI, right? Peak last, right? Because we just we have pour in this kind of brackets in the DQ dot pour last. And we always need to have that deck to add a last current index. So in the end, we just return um, result. the first um, is empty. Method is empty, and why this is not empty. If this is not empty, I minus stack. This is not we define this is deck, right? So this is DP, sorry. And let's also write a Python code for this. Um, so let's have n equals n that's called dq, okay, def and dp, right? N equals that's dp. This will be length of nouns, and this will we need to import from collections import dp, right? So then we have dp equals this one multiplied by n result. Let's set as float minus so then what we do is the for I in range, and uh, we are going to have if the deck is not empty and I minus deck 0 is greater than k, right? So that means the deck top is out of boundary. We need to have deck top left. Right? So after this, we can processing dpi equals nums I, right? So here we say if deck is not empty and dp deck 0, if this is greater than 0, right, we will have need this condition because we have options to connect with previous subsequences or not. If this is negative, we just start a new one, right? So we don't need. So if this is positive, then we have dpi add equal to dp deck 0, and result should be equals max result and dpi, right? Then on the other side, while the deck is not empty and dp deck that we pick the last one is small equal to dpi, right? Then we have to deep deck we can pop. And after this while, we should deck append I, right? In the end, return result. Um, the time complexity will be O n, right? Because every number will be put uh pour added to the deck once and then being pulled either from right last or first once. In the space, uh, the worst case will be store k elements, right? So um, here the syntax, but we also have a DP n, right? So that this is O n and deck is OK, right? Of course, actually, for this one, we don't need we can have a DP with size K as well because using some kind of rolling, right? But because I think this question K and N they have same order, right? So uh, space complexity let's set as O n should be fine.